Example number 1. The equation of an ellipse is 9x squared plus 16y squared equals 144. Find the coordinate of the center, the coordinate of the vertices along the major axis, coordinate of vertices along the minor axis, the coordinate of the foci, length of latus rectum, and eccentricity. So we are not scared to solve this problem because we know everything we need to be able to successfully solve the problem. So let's begin. So we have the equation given as 9x squared plus 16y squared I want to write it properly, then equals 144. Basically, we need to express this equation in standard form. The equations I gave you so far right from start were the equation of the ellipse in standard form. You understand? So the way it is now, we need to express it as that. So basically, when you have something like this, what we need to do is that you want to get rid of the 9 and 16. So we can divide through by the product of 9 and 16. Understand? So dividing through by 9 times 16. Dividing through by 9 times 16. 9 times 16. So we can see that this 9 can cancel out. This 16 can cancel out. And 9 times 16 can actually cancel 144. That's the product of 2 perfect squares. Yeah, that will give us a perfect square, which is that. Okay. So basically, we have x squared divided by 16 plus y squared divided by 9 to be equal to 1. Excellent. We have been able to successfully express it in the form that we are actually familiar with. Perfect. So when you have something like that in future, that's how you're going to do it. Okay. So now basically, remember, we said the equation is actually of the form x squared divided by. Now, before we actually interpret, let's look at the highest one. You can see 16 is the highest. So therefore, that will be the value of a. So that will be a squared plus y squared divided by 9 is b squared less than 16. That's excellent. Divided by 1. So I need the value of a. Let me take a squared set it to be equal to 16 to get the value of a. So thus a squared is 16, and it implies that a is equal to 4. By the time I take the root of both sides, the root of 16 is 4. Good. Similarly, b squared is 9, and it implies that b is equal to 3. Perfect. Please, are you following? Good. So now, the next thing is, since we have the equation, we need the coordinate of the center. Now, look at it. What would you see? Look at the equation. What would be the coordinate of the center? Since nothing else is attached to x and y, the coordinate of the center is 0, 0. C is 0, 0. As you can see, the equation actually looks similar to the equation of ellipse that is centered at the origin. Nothing is being attached to the value of x and y. Okay. If I thought something is attached to it, you will take what is attached to x, you will take it along with the sign with it. Then you opposite the sign, you alternate the sign. Let's say, okay, it's like x minus 2 now. Then your answer now along the x-axis will be plus 2. You alternate the sign. Okay. And if this one is like y plus 1, you alternate the sign and it will be minus 1. Simple as that. In case it is not centered at origin. You feel me? Exactly. So now, the coordinates of the vertices. We have answered this one. This has gone. Let me mark it in red. Let's mark it in red. So we need the coordinate of the major vertices along the major axis. Excuse me, along the major axis. Okay. Now we said MV, capital letter MV, for an ellipse. Okay, I actually have to ask one question right from start. Is this ellipse, is it horizontal in orientation or vertical? What would you say? Pause the video and answer this question. Answer it in the comments. Let me know. Excellent. I don't know if you get it anyway, but I know some of you actually get it. So it's actually horizontal because 16 is the highest value and it's actually under the x-axis. This means that the ellipse is elongated along the horizontal axis, which is along the x-axis. Thus, it's an ellipse with horizontal orientation. If that is the case, the MV, that will be equal. That will be, the first one will be plus or minus a comma 0. Okay, I already combined it. No, first one and second one combined. Okay, that will be equal to a bracket. What's the value of a? That's 4 plus or minus 4 comma 0. I got that. Simple. Consider perfect. Now, coordinate of the minor vertices, lowercase mv. That will be 0, plus or minus b. And that will be 0, plus or minus 3. This is b. Excellent. Next one, coordinate of foci is an ellipse with horizontal orientation. The value of c will be along the x-axis. Coordinate of foci will be plus or minus c, 0. So we need c. C squared is a squared minus b squared. This is what I'm saying. At this point, we need this equation. Am I communicating? We need this equation. C squared is 4 squared minus 3 squared. That's 16 minus 9. C squared equals 16 minus 9. That's 7. C squared is 7. Taking the root of both sides, c is the root of 7. Thus, we have the value of c. So I'm putting that somewhere around there. C is equal to root 7. Am I communicating? Thus, we have it to be plus or minus root 7, 0. Perfect. Length of latus rectum, LR, is equal to 2b squared over a. That's 2 times b squared is 9 divided by a is 4. And that's 18 by 9. As the product of 9 and 2 is 18. And in fact, I got 9 instead of 4. And if you will reduce this, that should be 9 by 2, which is 4.5. But I leave it as 9 by 2. Eccentricity, lowercase e, is equal to c by a. C is root 7. And the value of a is 4. So you can put this into your calculator and get your value in decimal. And that gives us the solution to example number 1. How do you grab it? Now let's consider a situation where we have an ellipse that is not centered in the origin and then compare the difference. So